Good day. My name is Glenn Pierce. I'm a member of the ISTH Gene Therapy Working Group, and I'd like to talk to you today about a presentation made at EHAD in Frankfurt, February 2024, by Ashraf Ali Ismail from BioMarin and his colleagues on human liver biopsy analysis reveals lower RNA transcription may contribute to a decline in factor VIII levels following AAV5 factor VIII gene therapy. So this is an important study that looks at biopsies in patients to try to understand why the factor VIII levels have been declining in a number of these patients at the molecular level. So they've looked at the transduction efficiency. They have quantified the episomal forms of the vector RNA that form within the nucleus. They've also quantified transgene expression at the RNA level and correlated it with factor VIII activity at the protein level, and have examined liver histopathology. These are all the biopsies that they collected. I think it was about 15 of them. And you can see that on the y-axis, the patients who had the most recent factor VIII activity level made at the time of the biopsy at the chromogenic, using the chromogenic assay. And at the x-axis is as a function of time over the original AAV5 factor VIII infusion of valoctocogene roxaparvovec. And so you can see that the biopsies varied from within the first year to 4.1 years post-infusion. And the patient's factor VIII levels varied from less than 3 IU per deciliter to 87 IU per deciliter. Looking at the episomes, these are the circular double-stranded DNA that persist within the nucleus. And so as the single-stranded DNA comes in from the AAV that's delivered it to the cell, it's got to transverse the cytoplasm, get into the nucleus, where double-stranded DNA is created and then is converted into an episome that is stable and resistant to degradation. The overall concern about the liver is that hepatocytes continue to replicate, but as we can see here, the episomes remain very stable in these patients taken at a variety of different time points. There are overall about 3 to 4 copies of the circular episomes per diploid genome within the entire liver. So that's an important finding, looking at stability at the DNA level in these patients. Looking at the RNA level, however, it does influence the factor VIII response. And so we had 2 patients who had factor VIII levels that were under 3 IU per deciliter, and the rest of the patients had factor VIII levels that were over 3 IU per deciliter. Those that were over 3 IU per deciliter had 78 plus or minus 51 transcripts per nanogram of RNA. But the 2 low patients who started off high, as you can see from this factor VIII activity graph here, both of these patients are shown, one in blue, one in red. Their levels started off in the 20-30% range, but then dropped down to very low levels, under 3%. And so both of these patients, although they had two copies of DNA per diploid genome, which was very good, they did not have sufficient levels of RNA, very low levels of RNA, 0.2 and 1.7 transcripts per nanogram of RNA, compared to the 78 transcripts per nanogram of RNA seen in the patients who had higher factor VIII levels. So the RNA simply wasn't being made in these 2 patients, although the DNA was present. So that's an important finding in in this study, and it remains to be understood why the factor VIII RNA has gone silent and is no longer translating factor VIII protein, but important clues that will allow for further investigation. Importantly, the full-length circular episome levels persisted. They did not decrease, so the DNA remains stable. RNA is silenced, and the reasons for that remain to be determined. They'll also be continuing to look at these biopsies for additional safety issues, including the mechanisms that may be mediating the transaminitis seen in the majority of patients in the valoctocogene roxaparvovec studies. Thank you for your attention.